In this lesson, we're going to look at period and phase shifts of a sine and cosine function. For here, the period is the amount of time it takes for one complete cycle. That is a definition of a period. So if you look in the previous lesson here, we can see that the period of a cos function, if we say it starts here, then one cycle is where it repeats right here, and then it's just going to repeat again and again. So every sine and cosine function has a period, and so does every trigonometric function. The normal expectation for a sine x and cos x function is that it's a period of 2 pi. And we can draw a sine function here. It says here, draw a sine function that has a period of pi. So we can imagine that the sine function is supposed to look like this, and then it would repeat itself. This one says a period of pi, so it means pi would go right there. That would mean that this is pi over 2. Right here we have pi over 4, because that's half of pi over 2. And this would be 3 pi over 4. I'll get back to this in 1 second. So k affects the period of the function, sine kx and cos kx. The new period of the function can be found using this formula. So the period is equal to 2 pi over k. So in this question here, we have that the period is pi, and we're supposed to write a function for that. So the period equals 2 pi over k. So we're going to put pi in for the period, and 2 pi over k. On the other side, we need to solve for k. So simply we would multiply both sides by k to get that k to the top there. Now we have k pi, which sounds like a cool band name. And then we'd have 2 pi over here. And then we would take the pi from that k and divide it out. And we would have k equals 2. So the equation would be y equals sine, and we're putting in a value for that k value, so we're going sine 2x. And there we'd go. That would be the equation. It says here, sketch a graph and write an equation of a cosine function that has a period of 8. I'm just going to draw a portion of one here. So we have here, like that. We'll call this 2, 4, 6, and 8. It's a cosine function, so if you remember, we'll call this 1 and -1. So cosine function starts at the top here, and it's supposed to have a period of 8, which means in 8 units, it should be right back to where we started it and then repeating itself. So let's just take a look. A cosine function should look like this. Okay? Again, it starts at the top. Halfway through, what happens is it's at its minimum. So that means halfway between 0 and 8 is 4. So we should be down at that -1. Okay? So this is the min right there. And then halfway between the min and the max, we should have the equilibrium points. Okay? That's both of these. So we'd have a spot there and a point there. And this would be our cosine function that has a period of 8. And again, so we could repeat this over and over. So this would be 10, 12, 14, and 16. And after another 8, we should be right back to where we were. Halfway in between those two maxes should be our minimum. Halfway between the max and the min is our equilibrium point, and it just continues on and on, like that. There we go. That is a cosine function that has a period of 8. All right, now we're going to look at phase shift. So a phase shift is the distance that the graph moves horizontally. It is the effect of d on y equals sine bracket x minus d. And y equals cos x minus d. So we're going to take a look at the graph of cos x plus pi over 4, cos x plus pi over 2, and cos x minus pi over 2 right here. So if we look at cos and we add a pi over 4, notice that the green graph, which is the plus pi over 4, is actually shifted over. And let's make this go up by pi's here so it's a little easier to see. I'll make it go up by pi over 4's. That's even cooler. There we go. So you can see here that the green graph is shifted over pi over 4 to the left. So if it says plus pi over 4, it's actually pi over 4 to the left. If we were to look at cos plus pi over 2, it just shifts it over even more. So now it's shifted left pi over 2. And if we're to do minus pi over 2, you'll see that the black graph, that if we look at these two maxes here, that it shifted to the right pi over 2. So we have that cos x plus pi over 4 is a phase shift of pi over 4 left. If it says cos x plus pi over 2, it's a pi over 2 left. And if it says minus pi over 2, it would be pi over 2 to the right. Again, the thing in the bracket kind of works the opposite of what we would expect. Little cool thing to notice if you look at sine x and cos x, and we do sine x equals cos x minus. So I'm going to put a minus symbol in here. And I'm going to try and make my cos graph look like a sine graph. Well, what would it take to make my cos graph look like a sine graph? So the max is supposed to be at 1, and you'll see that's a shift of pi over 2 to the right. So if I put in pi divided by 2, we would get that without the pi over 2. Let's just take a look at that. So notice that the blue graph, to make it look like the red graph, the sine graph, we need to shift it over negative pi over 2. Okay. But also notice we could do this in different ways. Because there's a period, we could also shift it plus 3 pi divided by 2, and you would get the same graph because now it's just shifting it left. Those are all options we could play around with. So we had before that it was pi over 2. I want you to play around. What would it take to make the cos x graph, to make the sine x graph look like a cos x graph? So what would you need to add, and see if you can find that number. Okay, what you should walk away with in this lesson is in the relations y equals sine kx and y equals cos kx, k changes the period and can be calculated with the formula period equals 2 pi over k, as well in the form of y equals sine bracket x minus d bracket and y equals cos bracket x minus d bracket. D is the phase shift. Okay, and remember that if it says negative d, you're actually adding it, moving it right, and if it says plus d, then it's actually moving it left. And that's the end of this lesson on the effect of the phase shift and the horizontal stretch.